want to speak with you about the topic of climate neutral production. Perfect. Okay. So something about motivation, something about accounting. How do we do accounting in the manufacturing environment to get a sense of understanding how much we pollute and some aspects. So if you have questions, since we are just a couple of people, just raise your hand, just stop, and then I get into explanation. Where are you from? The USA. So some figures I present are figures from Germany. It would be interesting to see if you have equal percentages in the US. The first figure I always show is how much emissions does the overall industrial sector pollute. And when we look at the direct emission, it looks like, okay, 8% might not be that much. But the big piece of this cake is the energy sector in its own. And when we split the energy to the consumption, we then get 27%, where the industry, German figures, is polluting each year. And beside the energy sector itself, it's the prior two topic, more than transport, because everybody is speaking about the mobility sector, vehicles, and so on, more than the households. So industry is a major topic. It's flipped in the US. Yeah, so interesting. So that is the situation in Germany, and the title is Towards a Climate Neutral Production. And at the beginning, I also want to raise the different wordings and explain the different wordings. We always start explaining CO2 neutrality. CO2 neutrality means all sources and the things are balanced. That is CO2 neutrality. The sad side of the story is if we reach CO2 neutrality, the global warming still proceeds. So the next thing is, besides CO2, we have other elements and other topics which we then say those calculated in equivalence are required for the global warming. So methane as an example, and this means then the greenhouse gas neutrality. And top of all of this is like climate neutrality, which in fact, we, focusing on industry, we cannot really manage completely. But that would really count everything, all the human factor that influences our system. And when we reach the climate neutrality, then we would stop the global warming. So just a quick definition terms for understanding. And usually when the companies, when they proceed their journey towards climate neutrality, they have their way how to do it. And first of all, they have to do the accounting. And that's the topic which I want to to explain today how to do accounting on the product level. After reaching the step of accounting, we then can do measures to reach the CO2, the climate neutrality. And usually the companies, they start quite heavily looking at the compensation aspect. But that is unfortunately, in our opinion, not the best way to do it. I mean, that's a quick way to do a lot of compensation, but in terms of our all system, we should focus more on the aspects to minimize and to substitute the topics. What does that mean? Minimization can be reached by energy efficiency, by material efficiency, looking at the circular aspect, and so on and so on. So a lot to do. And we know studies. One huge study was done by Boston Consulting 2 years ago, because a lot of time companies ask, how much can I reach if I look on the energy efficiency aspect? And in this study, we see that we can reach 20% only looking at the energy efficiency aspect. And that is quite a nice level, which we can use. So the last year, especially in Europe, the substitution aspect was very interesting to look at. The increase of the renewables, the electrification, material substitution, green hydrogen, that would be altogether mean measures to substitute our current system of energy. I will skip the compensation aspect. Other things not be stated today in my short speech. Accounting, how to do accounting, how we get a product carbon footprint. The product carbon footprint, or in general, the carbon footprint, is a measure of the total amount of carbon dioxide emissions directly, indirectly caused by activities. And in addition to the carbon dioxide, the other greenhouse gases, I mentioned methane as an example, also need to be taken into account. Another question, how much CO2 equivalents in average we pollute per person in Germany each year? How many tons? Do you have a rough guess? How many tons of CO2 equivalents? Other questions. How many tons of CO2 equivalents we pollute flying from Frankfurt to Asia, for instance, to Thailand? How many tons? Oh, less. Five is good. So in Germany, each person is responsible in average for around 12 tons of CO2 equivalents. And a round trip to Asia roughly pollutes 3 tons. Yeah? And we as private persons, I think we get a better sense of understanding, okay, which actions we are taking each day, each week, each month are responsible for how much pollution, and how can we avoid the major pollutions. And the companies, they are starting, when they look at carbon neutrality, on a company level. They want to know, is our company climate neutral, or when do we reach climate neutrality? This is what you always read in papers, in magazines. They say, okay, company Bosch, for instance, is climate neutral since 2021. How do they reach this? Quite a lot with compensations. But also they start quite heavily investing in minimization aspects, in substitution aspects. So now, from the company level, the question is, how do we get on the product level? It is not the same. Where is the major difference? The major difference is, if you are familiar with the so-called greenhouse gas protocol, this standard divides into direct and indirect emissions. And the indirect emissions, again, are subdivided again into emissions that are directly occurs at the company level or in upstream, downstream activities. And when we look at the product level, the product carbon footprint, we definitely need to know a lot in the so-called scope 3 item, the indirect emissions that happens upstream and downstream processes. And that is quite hard to get. And now back in our production environment, we do see two steps in between the machine level, the area level, and in the investigation we've done since several years, we see that at least here, when we are not at the company level, when we are more heading towards the product level, that measurements, temporary or current measurements, they help to get the product carbon footprint. How can you measure? Looking at all these nice machine tools. Usually, we have electricity, even compressed air, typically is used by acquiring data from various sensors. Most of the companies are able to acquire those electric and the air-specific energy with sensors. Then others are only be measured temporarily or kind of manual acquisition. And we even have, like, looking at grease or hydraulic oil, for instance, as two examples. They look at their documents and are coming up with first rough estimation. Also valid, also possible, and this is where the journey began into our projects with the industrial partners to say, okay, what is the accuracy we have while allocating in such different ways? Thus, an continuous and standardized and automated way of measuring these different resources help for the product-specific carbon footprint. That is the explanation of these different scope items, which I've already mentioned from the greenhouse gas protocol. And there was in a large investigation 2 years ago from the German association, other companies involved, consulting companies, and they found out, for instance, that looking at mechanical engineering, almost 90% are coming from scope 3 items. Though that means you can start with scope 1 and scope 2 that are much easier to gather, to acquire, to account, but then you miss this big part of the cake. So after doing more than 5 years of research, investigations, development, I can say we have so-called top 3 items where we see the difficulties of accounting. One is the allocation aspect, the allocation of the resource consumption. Where does those consumptions occur in the first place? Who is responsible for it? Then, when you look at this value chain, especially in raw material, is always a question: where was this raw material produced? We have databases, material databases, where we say, okay, when we're machining kilogram of aluminium, how much equivalence in raw material we get into our process. But in future, we should look at how was this metal produced. Was it produced 100% by renewables? By green hydrogen? Or was it produced in the traditional way, based on coal? That would be a completely different story. So there we get really to difficulties, and the level of detail is always a challenge for our industrial partners when they say, okay, where are my hotspots? Where should I look in more detail? Where can I do a rough estimation? And so on and so on. Accounting. And I decided not to get too deep into the accounting aspect, because just 10 meters away here we have this nice small machine tool, which you can see here. The 2 gentlemen here in the black shirts around this demonstrator, they can show you after the presentation how we are doing a product specific product carbon footprint on a standardized and automated way. What can you see here? You can see that we are acquiring the data during the process. How much electric energy was used? We haven't installed the other energy sources here on the trade fair. How much energy was used? Then we are consuming the actual electricity situation in Germany. How much renewables are in the net for the moment? And all data points that we are collecting are described in a standardized way. Maybe you've heard from UMATI, OPC-UA. So we decided to collect those data points which are already defined in specifications, so that the step from this specific machine to another machine, to another country, to another vendor should not be an issue. So because I think personally this CO2 accounting, the balancing, it will get very relevant in the next years. customer, I think personally, they will have a look on the amount of pollution and will decide or which article to buy. Yeah? And if that gets relevant, it should be done on a standardized base. Otherwise, we are in big trouble. And this is what the two PhD students at the booth here, just 10 meters away, can demonstrate how we collect the product carbon footprint in a standardized and automated way. Because we have done in a project the accounting of a complete production line manually, and that is amount of work to do, a lot of work to do, a lot of decisions to take, and we thought, why that should be done in a more automated way. Some two last slides. Since I'm heading the Institute of Production Technology, you've heard from this factory, the ETA factory. We started with energy efficiency measures, with research on energy flexibility, also resource, so the material itself, and all topics together, in our opinion, are a perfect match to head towards the climate neutrality aspect. And together with industrial partners, we show how the accounting can be done with less effort in a standard way through all three scope items, to upstream and downstream processes. And then, after reaching this level of accounting, we show how to optimize by the minimization, by the substitution aspect. And if you are interested, ask the PhD students, the team from us, ask me afterwards. We have knowledge in the field of how to do these climate neutral transition steps, step by step. We can show you how to optimize the infrastructure of a production site and also the machines itself. And one thing that is a must to know is that a machine tool in its own will not reach this high efficiency, rather than looking at the complete network, keeping things together. And this heat topic that just ETA Solution, Mr. Beck showed, is a really, really important topic. What is a booster definitely is that we have a nice digital backbone. An environment where we can acquire a lot of data, look into the process, get the transparency, and so on and so on. And we, with our approaches, are able to also optimize the production equipment by using new algorithms, new techniques of controlling this. Beside conventional control, we have a lot of potential looking at data-based approaches, and this is what we have developed with all the PhD thesis at the ETA factory, in already transferring these technologies to famous industrial partners within Germany, within Europe, and that might be also a nice topic to discuss. How is the situation in the US? I think a lot of topics are comparable. Maybe not the topic of renewables in that big amount, because when you are reaching a level of 40%, 50% of renewables, the topic of energy flexibilization gets more and more relevant. Then you also have to react on the industrial side. Given with that, I would say I end my little speech open for questions. Thanks a lot.